Hi guys, I'm Nancy and I'm going to show you how to find the vertical asymptotes of a rational function. If you don't know what I mean by rational function, just ignore that. You're probably in the right place. Actually, all this stuff is a lot easier than it sounds, so don't worry. It's going to be fine. Let me show you. Okay, so say you need to find the vertical asymptote or vertical asymptotes if there's more than one. First of all, what is a vertical asymptote? It's basically an invisible vertical line that your graph approaches and gets really, really close to, but never actually touches, never quite reaches. So how do you find the vertical asymptote? Well, if you have a rational function, fraction form type, which is the most common kind for this, you can use the same 3 steps always to find the vertical asymptote. Okay, so here are the 3 steps you can always use to find the vertical asymptotes of a rational function. The first is to factor the top and bottom if you can, and all that you can. I'll show you what I mean. The second is to cancel any common factors from the top and bottom to simplify. And the last step is to take the bottom, the denominator, and set it equal to 0 to find the vertical asymptotes. So let's try it for this function. The first step is to factor the numerator and denominator if you can, and all that you can. So you can't factor the top in any way, but the bottom you can factor. It's a quadratic. And if you want more help on how to factor quadratics, I have a video for that, so you can check that out. But basically, it is you want to break this into 2 separate factors that start with x. So x plus a number times x plus another number. Okay, and what you want are 2 numbers here that multiply to 6 and add to 5. And those 2 numbers would be 2 and 3, since 2 times 3 is 6 and 2 plus 3 is 5. So in here we have 2 and 3. And that's all that you can factor for this rational function. So that's the first step, you factored. Second step, see if there are any similar terms on the top and bottom that you can just cancel out. In this example, there are not any. The top has different factors from the bottom completely, so you can't do that here in this particular case. So we move on to the last step, thankfully, which is to take the bottom, the whole denominator, and set it equal to 0, and solve for the real zeros of the denominator. So take the whole bottom and set it equal to 0. And to solve something like this, you may already know this, but you have to take each factor separately and set each of these equal to 0 individually. So take each of these and set them equal to 0, and solve for x, get x alone. So these are your vertical asymptotes. If you solve for x in each case, get x alone, subtract a 2 here, subtract a 3 there, you have x equals -2 and x equals -3. These are your answers. The vertical asymptotes, if you have any, will always be at x equals some number or numbers, and they correspond to invisible vertical lines on the graph. So this is your answer. You don't need to do anything more, but I want to show you what this means. So let me show you that on a graph. Okay, so again, you don't have to graph this, but just so you know what the vertical asymptotes mean, these answers, x equals -2 and -3, correspond to dotted invisible lines, vertical lines on your graph at x equals -3 and x equals -2. And your curve or your graph will never cross those invisible vertical lines or touch them, reach them. So like up here in this branch, each side is shooting toward positive infinity if you go up, but when it does that, it will never go beyond x equals -3 or -2 on either side. And for these branches down here, same idea. They're each shooting down to negative infinity here and here, but they will not cross to the left of -2 or to the right of -3. So those vertical lines are, the asymptotes are where the function is not defined for x, where it does not exist for x. And I know that there's another dotted line on here, this horizontal one at y = 0. I'm not trying to confuse you. That is a horizontal asymptote, so it's different, and you find it in a different way from the vertical ones. I actually have a video on how to find the horizontal asymptote, so you can check that out if you want. But basically, in a nutshell, if you want to find the vertical asymptotes, if your function is in its most simplified form, the vertical asymptotes will be at x equals the real zeros of the denominator of the bottom. And now I want to show you kind where factors do cancel. Okay, so let's look at another one. Say you need to find all the vertical asymptotes of this, another rational function. It's the same 3 steps to keep in mind. So first, try to factor as much as you can. If you try to factor the top, this is a quadratic that you can break into 2 factors. When you do that, when you factor, you'll want 2 numbers that multiply to -10 and add to +3. Those 2 numbers would be +5 and -2, since 5 times -2 is -10, and 5 plus -2 is +3. And now, see if you can also factor the denominator, x squared minus 4. I know that this looks different from the top. It's not a trinomial, there's no middle x term, but it is a difference of squares. 4 is a perfect square, so it fits into the difference of squares formula. So you can break this into 2 factors that start with x. And using the difference of squares formula, since 4 is a perfect square, that's 2 squared, this breaks into x plus 2 times x minus 2. And if that is an issue for you, feel free to look that up, the difference of squares. But you can also check this. If you've multiplied this out and FOIL this out, you would end up getting this back, so that works. Anyway, you've factored the top and bottom as much as possible, so that was the first step. Second step is see if there's anything the same on top and bottom that you can just get rid of, just cancel. Here, there is. The x minus 2 is on top and bottom, so we can get rid of it. Simplify by canceling it out and write what's left. And only after simplifying, like we did, do you take the denominator and set it equal to 0. That's the last step. Take the bottom, set it equal to 0. Solve for x. Which I'm sure you know how to do to solve for x and get it alone, but when you do, you get x equals -2. And that is the vertical asymptote. You just have 1 this time. That's fine. It came from what was left in the denominator after simplifying like we did. Those canceled terms, those other ones, did not end up giving us a vertical asymptote. So, by the way, what does this look like on a graph? And what happened to those canceled terms? What was that about? Let me show you. Okay, so here's what this looks like. Your answer was just this, x equals -2 for the vertical asymptote. On the graph, that corresponds to this dotted vertical line here, and for the curve, the graph, it will get very close to that dotted vertical line, but never cross it or touch it on this side and on this side. This other dotted vertical line is a horizontal asymptote, and so that's another topic. But I want to show you what happened to those canceled terms, just so you know. When that happens, it creates a hole in the graph, a removable discontinuity, because at that point, at x equals 2, it made this equals 0 and this equals 0. And whenever you get a 0 over 0 form, anytime, it is indeterminate as to the value. 0 over 0, by the way, does not equal 1. Does not. It's a special indeterminate form, and it will be this gap in your graph if you zoomed in close enough. So that's just good to know if you have to graph the whole thing. It doesn't matter for just answering what the vertical asymptote is. Now I want to show you one last kind of vertical asymptote problem. Okay, here's one last kind. This kind looks much simpler than the ones before. It just has a number on top, just a constant. But that could throw you off that it's so simple. So I want to show this to you. Still try the same 3 steps. So try to factor the top and bottom. Can't factor the top, it's just a number. Try to factor the bottom, x squared plus 1. Turns out you cannot factor that. If it had been x squared minus 1, you could use the difference of squares to factor, using the difference of squares formula, x plus 1, x minus 1. But since this is a sum of squares, x squared plus 1, can't factor. Go ahead and try. It's not factorable. So move on. There's nothing you can cancel either. So really, if you can't factor anything, can't cancel, just take the bottom and set it equal to 0. So take the denominator x squared plus 1, set it equal to 0, and solve for x. Okay, when you try to solve for x, you get x squared equals negative 1, and then at this point, to get just x alone, typically you would square root both sides. Here you get plus and minus the square root of negative 1. That is imaginary, complex number, and this means that you get no vertical asymptote. If you get no real solution in the real number system, so like a square root of a negative number, it is not defined in the real number system, so you have no vertical asymptote. And that's fine. You don't have to have a vertical asymptote. That happens sometimes. Let me show you what it looks like. Okay, so this is what the graph looks like here. There is no vertical asymptote, so there's no dotted invisible line where the function is undefined for those x values. There is a horizontal asymptote, but that's another story. So that's the graph, and then in general, to find the vertical asymptotes, just stick to these 3 steps for finding them for rational functions. Okay, so if you're up for more, I also have videos on how to find the horizontal asymptote and how to find the domain of a rational function. But I hope this video helped you understand vertical asymptotes. I'm sure learning about asymptotes is exactly what you wanted to be doing right now. It's okay, you don't have to like math, but you can like my video, so if you did, please click like or subscribe.